So in questions 1 through 4, they want you to determine whether the function is an example of exponential growth or decay, and then find the y-intercept. So all of these are kind of the same. And the way that you figure out if it's growth or decay is you look at the base. So this one says 3 times 0.25 to the x. So because this number, which is the base, is between 0 and x and 1, it's going to give me exponential decay. Exponential decay. Then the next part is, how do you find the y-intercept? Well, to find the y-intercept, you let x be 0 for anything. So if x is a 0, then 0.25 to the 0 is 1, and 1 times 3 is the number 3. So I'm going to have 0, 3 as my y-intercept. In this one, since 6 is greater than 1, we're going to have exponential growth. But then, of course, since I have this this negative exponent up here, it means that my graph is going to be looking something like, oh, hold on one second. Sorry, my pen froze for a second there. But anyways, so since I have a negative x up to the exponent, the graph will be going down. So that means that I'm going to have exponential decay. And when I plug in a 0 for x, I would have the point 0, 2 for my y-intercept. Number 3, I have the number base 10 raised to the power of x. So I'm going to have exponential growth because my 10 is bigger than 1 and my exponent is positive. And the y-intercept here is going to be 0, 0.1, since I'm going to plug in a 0 for x and solve. And then for this fourth one here, I have the number pi raised to the x power. Pi is about 3.14. Of course, that's greater than 1. So when I plug that in, it would be to get my y-intercept. So anyway, so I have growth here. And then when I plug my y-intercept in for a 0 for x, I'd have 3.14 to the 0 is 1 times 3 is the number 3. So I'm going to have the point 0, 3. And that's how you do all problems 1 through 4.